Namaste bachcho, welcome back to the channel. With your exams just around the corner, I know you're all working so hard. So today, we're going to quickly revise one of the most important chapters, statistics. We're going to find out the real story hidden behind the numbers. Oh, and before we start, if you haven't already, please subscribe and share this with your friends. And definitely let me know in the comments what you think. Okay, let's go.
Okay, so imagine you're the captain of the cricket team. It's a huge match, and you have to pick one of these two batsmen. Look at their last 10 scores. Batsman A. Wow, he has some big hits, right? Even a century. But look, he also got out for a 0. Now, batsman B, his scores are, well, not as flashy. So who do you pick? Who was the more reliable, the more consistent player you can count on?
Now your first thought is probably, let's just find their average. So you calculate the mean, and guess what? It's 53 for both of them. Okay, so what about the median? The middle score? That's also 53 for both. Arre bapre, how is this possible? If their central score is exactly the same, how on earth are we supposed to choose? This is a real puzzle.
Clearly, just looking at the mean or median isn't enough. It's not giving us the full story. We need some better detective tools, tools that can show us how the scores are spread out. In statistics, we call this measuring dispersion.
Let's just look at their scores on a number line. See batsman A? His performance is all over the place. It's totally scattered. I mean, he could hit a massive 117, but he can also get out on 0. He is so unpredictable.
Now look at batsman B. See the difference? All his scores are packed together. They're all clustered around that average of 53. He is incredibly consistent. You just know you can depend on him for a score of around 50 every single time. This visual difference, that is the whole idea of dispersion. So, let's look at our first and simplest tool to measure this spread. It's something called the range. Think of it as our first basic clue to understanding how spread out the data is. And how do we find it? It's super easy. You just take the highest score and subtract the lowest score. That's it. Maximum value minus minimum value. Simple.
So for our batsman A, the range is 117 minus 0, which is a massive 117. But for batsman B, it's just 60 minus 46, which is only 14. This huge difference, 117 versus 14, it immediately tells us that batsman A's performance is way more scattered.
But wait a second, the range is a bit limited, isn't it? It only looks at the highest and the lowest scores, and it completely ignores everything in between. We need a more powerful tool, something that looks at every single score to give us a much truer picture of who is more consistent.
And that brings us to our next tool, mean deviation. Now this is where things get really interesting. We're now going to look at the average distance of every single score from the center, from the mean.
The most important word here is absolute. See, some scores will be higher than the mean, and some will be lower, so we'll get positive and negative differences. If we just added them up, they might cancel each other out to 0. So we take the absolute value, which just means we ignore any minus signs. Easy.
The calculation is very straightforward, bachcho. Just 4 steps. First, calculate the mean. Second, find out how far away each score is from that mean. Third, just drop all the minus signs to get the absolute values. And finally, fourth, just find the average of those absolute values. Simple.
Let's quickly do one example together. For this data here, the mean is 9. So we find the deviations, right? Like 6 minus 9 is negative 3. Then we take the absolute values. So that minus 3 just becomes 3. We add all these absolute values up, we get 22, and we divide by the 8 scores. And our mean deviation is 2.75.
A mean deviation is useful, but in maths, just ignoring the minus signs, it's a bit of a jugaad. It's a quick fix. It works, but it's not very, elegant, and we can't do more advanced maths with it. So we need an even better, more scientific way to deal with those pesky negative signs.
And this brings us to the gold standard, the most powerful tools in all of statistics for measuring spread. Variance and its best friend, standard deviation. This is what the real pros use.
So how do we get rid of the negative signs without just ignoring them? It's simple. We square them. You know that any negative number squared becomes positive. So variance, which we write as sigma squared,
is simply the average of the square distances from the mean.
But this creates a funny little problem. If our original scores were in runs, the variance will be in runs squared. What is a squared run? It doesn't really make any sense in the real world, does it? It's a little bit confusing.
And here comes our hero to solve this problem, standard deviation. To fix that whole squared units issue, we just take the square root of the variance. And poof, like magic, we're back to the original units. If the variance was runs squared, the standard deviation is back in runs. So much easier to understand.
So listen closely. This is the most important thing to remember. A small standard deviation means the scores are very close to the average. That means high consistency, like our batsman B. A large standard deviation means the scores are spread all over the place. That means low consistency, like our batsman A. Okay, theory part is done. Now for the most important part for your exams. Let's solve a typical question that you might see on your paper, so pay close attention now.
Okay, here's the question. Find the mean deviation about the median for this set of numbers. Now, notice what it says, about the median, not the mean. This is why you must always read the question properly in the exam.
Right, so what's the first step? We arrange the data in order, from smallest to largest. Since there are 11 numbers, the middle one, the sixth number, is our median, which is 9. Next, we find the absolute difference of each number from 9. We add all of those up and we get 58. Finally, divide 58 by 11 and our answer is 5.27. See? Not so difficult, right?
Okay, bachcho, this is a very important slide. Take a screenshot right now. These are the 4 most important formulas from this chapter that you absolutely must memorize for your exam. Mean deviation about the mean deviation about the median, variance, and standard deviation. Just revise these well.
And that's it for a quick revision. Please don't be scared of these formulas. Just practice a few questions and I promise you, you will find them very, very easy. You've got this. All the very best for your exams, bachcho. You are going to do great.